So far, we have focused on reliability, which is a critical part of software engineering. But reliability isn't the whole story. It's just one piece of a much larger puzzle called software quality. Think about it. An application could be perfectly reliable. It never crashes, it never freezes, and it always gives you the correct output. But if it's slow, difficult to navigate, or has a terrible user interface, would you say it's a high quality product? Probably not. Software quality is a much broader concept. It includes reliability but also other essential attributes like functionality, usability, performance, and security. Functionality is nothing but does it do what it's supposed to do? Usability is nothing but it is easy and intuitive to use. Performance will be is it fast and responsive? Security is it safe from unauthorized access? All these attributes together determine the overall quality of the software. To manage all of this, we use a systematic process called Software Quality Management or SQM. SQM is the overarching process that ensures a software product meets all of its quality standards. It involves three key activities that work together: quality planning, quality assurance, and quality control. You may heard of these processes somewhere else. Quality planning. This is the first step. It happens before you write a single line of code. Quality planning is where you define what quality means for your specific project. You set the standards and goals. For a medical device, you might set an incredibly high reliability standard. For a mobile game, you might prioritize performance and usability. You are essentially creating a roadmap for quality. Next, quality assurance. This is the proactive process. Think of QA as preventing bugs. It's all about making sure your development process is robust enough to avoid introducing defects in the first place. This includes things like establishing coding standards, conducting design reviews, and using formal methods. QA is a check on the process itself. The goal is to build quality in from the start. Next technique is quality control. This is the reactive process. Quality assurance is a proactive process and quality control is the reactive process. Think of QC as finding bugs. It happens after the code has been written. This is where your traditional testing and code reviews comes in. You are actively looking for defects that might have slipped through the QA process. QC is a check on the product. QA is check on the process itself. QC is a check on the product. There's a difference. You are inspecting the finished product to make sure it meets the standards you set during the planning phase. To simplify it, just remember this. QA prevents bugs while QC finds bugs. I hope you understand. Together, quality planning, QA and QC form the complete framework for managing and ensuring that a piece of software isn't just reliable but truly highly quality. We'll move on to the next slide. In this slide, we are going to see about a framework for improvement, the SEICMM. How does an organization go from having a chaotic software development to a process that consistently produces high quality products? The answer lies in the SEI Capability Maturity Model, CMM. The CMM is a roadmap for improving a company's software development process. It's a framework that helps organizations assess where they currently stand and provides a clear path to get better. The model defines 5 distinct maturity levels. Each level represents a high degree of process discipline, consistency, and control. Think of it like a learning a sport. You don't become a professional athlete overnight. You start with basic skills and gradually move up to advanced techniques. The CMM works the same way for software teams. In the next slide, we will go through the each levels. Let's walk through the 5 levels. Level 1, Initial. This is the lowest level. The process is ad hoc and often chaotic. Success depends entirely on individual heroes, a single highly skilled developer who can save a project. There is little to no formal process. Projects are often late and over budget, and the quality is unpredictable. It's like a pickup game. You are just playing with no set plays or team strategy. Level 2 is Managed. At this level, the organization starts to get its act together. They establish basic project management processes. This includes tracking cost, schedules, and requirements. A team can now repeat earlier successes because they have some basic processes in place. It's no longer about individual heroics. It's like a team learning to run basic plays consistently. Level 3 will be Defined. This is the major step up. The entire software development process is documented, standardized, and integrated across the whole organization. Every project uses an approved standard process. There are clear rules for how software is developed from designing to testing. It's not just a collection of separate projects anymore. The whole organization is on the same page. This is like a team having a playbook that every player knows and uses. Level 4, Quantitatively Managed. At this level, the organization becomes data-driven. They collect detailed metrics on their software process and product quality. They use this data to quantitatively understand and control their projects. They can predict with a high degree of certainty what project's quality and schedule will be. This is like a professional sports team using statistics and analytics to make strategic decisions. Level 5 is Optimizing. This is the pinnacle of CMM. The organization is focused on continuous process improvement. They use the data they collect in the level 4 to proactively identify and implement process changes to make things even better. They are always looking for ways to innovate and refine their methods. It's like a champion team that constantly analyzes its performance and adapts its strategies to stay ahead of the competition. By moving through these 5 levels, an organization can transform its software development process from unpredictable chaos to a disciplined data-driven engine for quality. We'll move on to the next slide. So, why does all of this matter? Why do companies invest so much time and money in this? Because it gives them a competitive advantage. Companies like TCS and Infosys are globally recognized for their ability to deliver high-quality, reliable software. They didn't get there by chance. They got there by embracing frameworks like CMM and systematically improving their processes. They have achieved high maturity levels, which means they can consistently deliver on their promises. Their clients know they can trust them to build complex, mission-critical systems that work and keep working. This ability to consistently produce reliable software is what builds a company's reputation and its bottom line. It's the difference between a one-time project and a long-term client relationship. That concludes our concept on software reliability and quality management. I hope this gives you a comprehensive understanding of these interconnected concepts. Remember that quality isn't an accident. It's the result of a deliberate, planned process. Thank you.